Okay, so we're going to be looking at a direct current, which is an example of what you do when you have a electrolytic cell. So the first thing you're going to do is obviously write down and find your equations that and half reactions that go with the solution you're given. And then obviously what you're going to do next is you're going to determine which one's oxidation and which one's reduction. Now, it's a little different in the case of electrolytic cells because basically the one that's an anion goes at the anode and is oxidized, while the one that is a cation, it goes to the cathode and is reduced. Even though this doesn't give you necessarily the highest positive charge. That's actually the thing with electrolytic cells. They actually are non-TFP and are normally going to be negative, and have a negative ecell. So we can now rewrite our bromine to be our oxidation since it was originally in reduction, and we can get those charges. Now what we're also doing here is we're going to have to compare it to these water equations and charges because it's in an aqueous solution with water, and so we have to compare them and see which ones have the most positive values. And out of these most values, our most positive is going to be the bromine for the oxidation and the water equation for the reduction. Now, if you notice, you also have to keep in mind that they are two different equations and you have to rearrange them as so. Like this one you have to rearrange on top first so you can get that negative value right there. And I like to remember that this one is the one that you have to rearrange because it's the one that produces oxygen, so it's going to be oxidized. Anyways, so continuing, again, those are going to be the two ones you choose, and then you just continue on like normal, and you use your equation, and you plug in your numbers in, and you get the voltage. And that's how you do electrolytic.